Okay, if we move on to number 16, number 16, there we go. Number 16 is looking at what type of intermolecular forces. So in order to do the type of intermolecular forces, we have to know what kind of compounds we have. In our first one, we have AlF3. We already said that he was ionic, which means he's going to have a negative positive end, which means he's going to be polar. And polar things are going to have dipole interactions. AlF3 has no hydrogen, so there's no hydrogen bonding. NH3 is the next one, ammonia. He's going to be a covalent type bond because he's going to have this structure, the pyramidal structure. He's going to be polar as well, which means he will have dipole interactions. But we also see a lone pair of electrons and hydrogens present, so we will also have hydrogen bonding occurring. Remember, we said that hydrogen bonding was the attraction between covalently bonded hydrogens and lone pairs on either that molecule or another one like it. H2S is our next one, very similar to H2O. So we're going to have sulfur bonded to two hydrogens. Sulfur needs 8, so he'll be keeping 2 lone pairs. This one would also be polar, which means we're going to have dipole interactions. And you see that the sulfur is keeping 2 lone pairs, and there's hydrogens, so we're going to also have hydrogen bonding. Our next one is oxygen, the diatom. When you look at oxygen, we've got this double bond. No way to split oxygen from oxygen, so it's non-polar, which means we're going to have dispersion forces at work, just drifting around, bumping into each other, and moving away. Our next one, CH4, methane, going to be a tetrahedral. It is a symmetrical model, which means it is non-polar, which again means dispersion. NaCl, going to be ionic, going to have a positive end here with the sodium, negative end here with the chlorine, so that would be polar. Got no hydrogens present, so it'll just be dipole interactions. CO2, going to be a linear model. Remember, this is the one that has the double bonds. Now, a way to split the carbon from the oxygen, so that's going to be non-polar. Dispersion. SO2, going to be lots of electrons floating around here. We certainly can split the sulfur from the oxygen, so it's polar. We'll have dipole interactions. And our last one is magnesium chloride. He's again going to be ionic. Magnesium will give his electrons to the chlorine. The chlorine will become negatively charged, magnesium positively charged. That means we're going to have polar. No hydrogens present, so we just have dipole interactions.